Good afternoon, everyone. Thank you for joining part 1 of the UAS webinar series on advanced flight planning. My name is Ryan Frankhauser, and I'll be your moderator for today's panel. Today we're going to talk about flight plan optimization, routing constraints, and we'll go over routing best practices and contingency best practices, with a focus on ETP best practices. When it comes to flight plan optimization, we're going to talk about two different kinds. The first being estimation planning. Estimation planning is a more simple technique which takes the total distance in kilometers and divides that distance by the average airspeed of the aircraft. So in our example, if the flight is 3,300 kilometers and the average airspeed of that airplane is 511 kilometers per hour, we get a resultant flight time of 6.45 hours, or 6 hours 27 minutes. There are some pros to this method. The first is that it's a fast and inexpensive way to determine rough flight times. Tools that utilize this method are often free or no-charge solutions. This is also the method that most scheduling softwares use. However, there are drawbacks for using this type of planning. First of all, typically these routes don't include any horizontal or vertical navigation data. They can be extremely inaccurate in terms of flight times and fuel burns, and they typically don't provide acceptable ATC routings. And as such, they're typically not used in advanced or international flight planning. Now, performance planning is a different story. Performance planning takes the OEM data for the aircraft, which is normally granular to the level of every 1,000 feet and every 5 degrees Celsius of temperature. So in performance planning, all flight plans are optimized with actual temperatures and winds. This tends to yield highly accurate flight times, fuel burns, and estimations. It can be used to derive flight plans which take advantage of all optimization types, and users can save money based on these optimizations since it's no longer just an average. Now, the downfall for using this type of planning is that this planning requires detailed aircraft performance data from the OEMs and accurate route catalogs, and this is typically what you're paying for your subscription-level flight planning services. So let's take a look at estimation planning versus performance planning with this simple chart. We have an aircraft in flight, and if we look at estimation planning, we can see that all the winds and temperature data is estimated. The performance data is estimated. But when you get to performance planning, you get far more information. You get accurate and actual winds and temp data, and you get OEM performance data. In this scenario, you can actually see that we're providing step climbs based on the performance planning, which is a feature that's typically not available with estimation planning. So now that we've established that performance planning is really the way to go, let's talk about the basics of optimization. When you have 2 points, the fastest way between those 2 points is a straight line or an optimized route. However, flight plans can't always be that wonderful. So any time that you deviate from that optimized route, you end up costing yourself both time and money. Let's look at a more practical example where we have Airport A and Airport B with nav aids and waypoints and fixes in between. Again, let's draw the most optimal route, which is a straight line, the Great Circle line. And now let's give you a route that the flight planning engine is most likely going to come up with. You can see it here depicted in purple. And you can see that we're trying to stay as close to the optimized line as possible. So, flight plan optimization is finding the route closest to the Great Circle line, which is acceptable by air traffic control. Most advanced flight planning systems offer multiple types of optimization. Time optimization, finding the shortest flight. Fuel optimization, finding the lowest fuel burn. Cost optimization with the lowest operating cost. Or ride quality optimization for our more nervous flyers. The main optimization factors for most advanced flight planning systems are time and fuel. But the real question is the entire flight from Airport A to Airport B optimized? Well, not technically. So what we have here is Airport A and Airport B. We're going to draw departure and arrival areas shown in 45-degree swaths. As flight planning providers, we know that Airport A's departure procedures are probably going to be standardized to some sort of departure radial. And since we know that you guys don't want to copy a brand new clearance when you fly, what we have done is pre-populated these departure and arrival procedures into our flight planning engines to give you the route that you're most likely going to get. So in our example, departing Airport A on a 0 to 45 degree heading will most likely give you this route. And the same is true for the arrival into Airport B. Arriving from the southeast, ATC is most likely going to give you this route. Now these are fictional routes that vary for every single airport, but what's most important here is what happens next. The point where the known ATC routing ends is called the pitch point, and the point that the ATC routing for the arrival starts is called the catch point. Therefore, our job as flight plan providers is to find you an optimizable route between the pitch and the catch point. Now the hashed line is our direct line or great circle line. And our job is to get you a route that's acceptable to air traffic control that is closest to that line. The purple line being drawn represents the most optimal flight plan that's acceptable to air traffic control. Now that we've talked about optimization, let's talk about routing constraints. This is what I call the international conundrum. Things can be quite a bit different outside the United States. For example, no direct routing. Unless you find a really nice air traffic controller, you're most likely going to be on published airways for your entire route of flight. And some of these route structures, they're complex. Some even seem nonsensical at times. And then we have local routes, which, as the name might suggest, are routes that can be flown only by aircraft registered in that country. This is very popular in places like India and China, and these routes sometimes show up on all of the maps, which can be very misleading. And then we have changes in altimetry, where you move from an imperial flight level to a metric flight level. This happens in Russia, China, and other places in Asia and the Far East. And then we start getting into permits, like overflight permits and landing permits, where we must obtain permission from the countries being overflown to traverse their sovereign airspace. More on permits in the next couple slides. And those same countries issuing us those permits are most likely going to want you to enter and exit their airspace at very specific points, called entry and exit points. And slots, whether they be airway slots or airport slots, landing slots, parking slots. But slots, or the permission to be somewhere at a certain time, they're pretty important too. So how do we overcome these constraints? Well, for starters, we use the integrated functions of our flight planning engines. We have the ability to route to include airways and specific waypoints, and at the same time avoiding those airways and waypoints. We have the ability to avoid FIRs and airspaces, and we have the ability to avoid or specify to fly over certain countries. And we also overcome these routing constraints by using flight planning best practices. So let's talk about some of those best practices, and we'll start with permits. The following things are important to consider when you're dealing with overflight and landing permits. First and foremost, you need to know if they're required for your type of flight, because each country has different rules and regulations based on the type of flight, whether they be private non-revenue or non-scheduled commercial or scheduled commercial or what have you. You're going to need to know the lead times that are required to get that permit as well. You also need to make sure that you understand that permits are contingent on the airports and the overflown countries along your route of flight. There are a number of countries that won't offer permits or approve permits for aircraft departing from or landing at certain airports, as well as some countries that are being overflown along your route. Now, you probably need to work with your service provider or your dispatch group to determine the flexibility of those countries you want to overfly, and see if they're willing or their willingness to accommodate permit revisions or amendments, because some countries might be very easy to deal with and tell you that you have long validity periods and you won't have any problems. Others, for example, Russia and China, don't like you making changes to their permits. You might even put your permit at risk by making a change. And finally, you need to be aware of any carriage restrictions, including the passengers with certain passports, or the contents of the flight, or the purpose of the flight, because the things that you carry on the aircraft and the reason that you're flying might have some impact on the ability to obtain an approved overflight permit. The permits also might contain restrictions that you need to be aware of, and you need to pay close attention that you follow these restrictions. Let's pull up an example. Let's overlay Riyadh, Saudi Arabia onto the screen. Your permit's most likely going to tell you that all of the alcohol on board the aircraft must be locked and stowed during the time which you're overflying Saudi airspace. So one of the ways that we handle the routing constraints when it comes to permits is using the route via airway or waypoint feature. Now, you typically tell your flight planning engine that you want to route via a specific airway or waypoint for a number of different reasons, one of which being the permits, when that permit requires you to use certain points along a route of flight. The other can be something as simple as overflying an AGME station for RVSM compliance reasons. But in this case, let's look at the permit example. And in the example below, you'll see an overflight permit approval from Venezuela. In the example, it tells us to enter Maiquetía, FIR, which is Venezuelan airspace, via the waypoint Armur, and to exit Maiquetía airspace at the point Povla. It's telling us with the RR that we're allowed to random route within their airspace while flying over their country. So how exactly do we do that in our flight planning engine? Let's transition over to UAS Flight Evolution and have a look. In this flight plan, we're going to go from Miami down to Brazil, using that permit that we got from the Venezuelan authorities. We do this by simply including the waypoint in our routing constraints. So let's add the first waypoint, which is the entry point, and now let's add the second waypoint, which is the exit point for Venezuelan airspace. We'll give it 2 or 3 seconds to compute, and then once we do, you will see that the optimized flight plan now includes those 2 waypoints, giving us a compliant route based on our Venezuelan overflight permit. I need to bring something up here. I get asked this question a lot as a service provider. Do I get the permit for the country or the FIR? Well, the answer to that is the country. And in this example, I've shaded the country of Ghana in orange. Ghana owns the right to all of the airspace above the orange. In addition, since Ghana is on the coastline, Ghana also owns the airspace up to 12 nautical miles off of the geopolitical boundary. So in this case, if I'm flying anywhere within the orange, or the dark orange line, which isn't to scale, I'm sorry, then I need to obtain a Ghana overflight permit. Oh, but wait, now things are going to get complicated. What if there's multiple countries in the same FIR? Like what we have here in Central America, where 5 countries are all part of the same FIR. The answer is that you still need to obtain the permits for each country. However, in this case, they are all administered through the CENIMAR or Cochenza agency. To obtain these 5 permits, all you need to do is contact CENIMAR, who's the controlling agency, and they will offer you the assistance that you need. But before we go any further in this country versus FIR debate, let's go back to learning about another one of the route constraints that's available in your flight planning engine. This time, we're going to avoid a country because we don't have a permit to overfly that country. So now that I'm back in Flight Evolution, let's go from Miami to Maiquetía, but we want to avoid overflying Cuba. And we do that with the route constraint called avoid country. Once I select Cuba from the drop-down list, then I go back to my route of flight. My optimized route should no longer route me over the Cuban landmass. So when do you avoid a FIR or avoid a country? That's another question. Well, in most cases, the permits are based on the country borders, and passage through the FIR does not necessarily require a permit, but passing through the country borders does. So, for permit reasons, you typically avoid the country. Now, when do you avoid FIRs? Well, you do when NOTAMs present problems with the FIR, or when operations are restricted, or when traffic or congestion will slow your progress, or when relatively close FIRs provide better surveillance and navigation assistance. You can also do it in the case of administrative disputes or having your account status in arrears, the latter of which is not very common, but it does happen sometimes. And there are certain countries that are notorious for late billing, sometimes months or years after the flight. Your accountant might have just missed the invoice, and therefore you're prohibited from the FIR or the airspace. I've included an illustration on this page because I want to show you something. From Miami to SVMI, which is a different flight plan than what we just ran. I included it because this is another option in some cases. The flight plan enters the Havana FIR, but does not overfly the Cuban landmass, therefore not requiring an overflight permit. This is an option if you can spend a few more minutes en route, or if you simply don't want to obtain an overflight permit. Now here's a tidbit for the people on the line who aren't actually flying much international. You can also use the Avoid FIR feature to avoid air traffic control centers in the United States, because technically those air traffic control centers are FIRs as well. You can see that every single route of flight that the system offered you takes you over the Indianapolis Air Traffic Control Center. So let's go ahead and avoid that FIR by selecting it from the drop-down box. And then once the flight plan computes, you will see that the optimized route no longer overflies the Indianapolis Air Traffic Control Center. This is good when there are ground stops or flow control issues or TFRs. Now, wouldn't it be fair for me not to tell you that most advanced flight planning engines already handle a lot of this stuff for you? For example, if we look at a popular route between Athens and Dubai, you'll notice that the routing gets a little tricky because of the geopolitical climate. For example, we can't overfly Syria. Israel doesn't allow overflights, and since we're going to the UAE, we can't overfly Qatar. But our flight planning engine handles this automatically, because when I go from Athens to Dubai, my optimized route, when I select from the route advisor, automatically suggests the more prudent southern approach down through Egypt and across Saudi Arabia. As an added bonus, these are all Eurocontrol compliant routes as well. Now let's take a look at some other best practices. Whenever you're picking international routes, you should always pick routes that are reasonably safe and free from conflict, if possible, even if they're not optimal. You do this by consulting the NOTAMs, obtaining intelligence and security reports for all areas of overflight, by checking with your service provider or your corporate intelligence team early in the pre-planning stages, and making sure you have approval from your insurance carrier to overfly these countries. So you need to avoid military action areas, areas of civil unrest, war. And it's not just for overflight, but the question is, what if you were forced to land? I've included an example of a service that provides intelligence information. And there are a number of companies like this that work across the globe to make sure that the flight departments that operate internationally have all the information that they need. One of the more important things I can say is that make sure you utilize all available resources. All of the routes that we're talking about, every route for every country is supposed to be in the Aeronautical Information Publication, or AIP, for each country, and most of these AIPs are available online. Here's an example of one for the Czech Republic, which is available online. If you're a Jeppesen subscriber or a JetView subscriber, the preamble sections are excellent sources of information. The aviation community forums and advocacy groups like MBAA, the IOC, and others offer fantastic resources for international flying, including the International Operations Database, which has real practical information written by other pilots that you might find of use. And of course, you should rely on your international service providers, because we deal in this arena every day, and we might be able to help you with something that you're not thinking of. And just to close out our discussion on best practices for routing, use published routing for all non-US sectors. Make sure your aircraft has the correct equipage to fly legally on your proposed route. Avoid all restricted, contested, and militarized zones. Understand that deviations in times can result in permit and slot nullification. So please tell your passengers in many of these places they need to be on time and you need to stick to the proposed schedule. Make sure your insurance covers your proposed route of flight. Plan for contingencies, confirm and reconfirm. So now let's start talking a little bit about one of the more popular contingencies. Equal time points is a hot topic in our community. The textbook definition is, quote, the geographic location along the route of flight where the time to return to an airport behind the aircraft is equal to the time to proceed to an airport in front of the aircraft. But regardless of that definition, in practical terms, we all know it as the scenarios that are computed to inform the crew the correct course deviations for a number of emergency scenarios. The first scenario is the medical scenario, where you have a critically ill passenger or crewmate aboard. All aircraft functions remain normal, but we're looking for the fastest possible route to a suitable airport. The second scenario is the loss of an engine, or more than one engine. In this scenario, we're going to descend to an optimal flight level for single-engine flight and then continue the flight on single-engine performance. The third scenario is the loss of cabin pressure, and in this depressurization scenario, we're going to immediately descend to an initial flight level, followed shortly thereafter by a descent into the final flight level. Contingencies are run for each of these scenarios, and we can plot those points on a map. The ETP calculations will either have you return to the coast-out airport, proceed forward to the coast-in airport, or divert to the tertiary or alternate airport. With these calculations, you will know exactly what to do, and you won't be left to guess. Selecting the best airports is very important when you're doing ETP planning. This is a pet peeve of most of us in the industry who do flight planning on the behalf of others. People are so willing to take a North Atlantic crossing with Gander as a coast out, Shannon as a coast in, and Keflavik as a tertiary airport. But you really need to look at it as more than that. You really need to look at this as airports that have the services and infrastructure you need. The availability of services, fuel, equipment, the availability of hotels and accommodations, of modern healthcare facilities, or the suitability of receiving parts and performing maintenance for AOG aircraft. Take a close look at the weather at the airports you're picking. The weather affects more than just your flight. It affects the ability of the service providers to deliver service, the ability for the healthcare professionals to render aid, or the ability to find hotels or accommodations for the night. Take a look at one of the approaches into Goose Bay on the right. Is this really an approach that you're interested in flying on a single engine or with a critically ill passenger? Take the time to pick the correct ETP airports, because if you need to use them, you will most likely be in an emergency situation. Okay, so this applies just over the water, right? Well, if I take a look at this barren landscape, it doesn't look much different to me. Okay, just over water and deserts then, correct? Let's take a look at this simple example. Airport A to Airport B. Great weather, no problem, normal flight path. Until the unfortunate happens. And we've depressurized. Our route of flight's now gone. What do we do next? Well, we're going to descend, and we're going to fly at a lower altitude until we can get to where we're going. Not a problem, right? That mountain could be a problem with the wrong meteorological conditions. Now, this example was given slightly tongue-in-cheek, but it does raise a valid point. You always have to be ready with proper contingency planning. Now, in conclusion, please always remember that outside of the US, plan all your flights on published airways. Make use of all the available resources you have, including the AIPs that are available on the internet, your international service provider, and industry discussion forums. Determine whether or not to obtain secondary permits for nearby countries for contingency planning. Or consider ETP planning even when you're not over the water. More importantly, choose ETP and alternate airports with the understanding that in the unlikely event of an emergency, you may actually have to use them. You should consider investing in a true performance-based flight planning system. And most importantly, confirm and reconfirm everything before you fly. Thank you for attending this demo. On behalf of UAS International Trip Support, we wish you blue skies and safe travels.